Hello everyone. This is the video tutorial for the sound lab. For this lab, you're gonna need Stellarium. And in this lab, you are going to be exploring how the sun moves with respect to the horizon and the equator at different times of the year. You're gonna explore the altitude and latitude of the sun and the cardinal positions as you go through time in the year. So if you have a stellarium, it will look like this. You have by this time done a couple of labs using a stellarium. In here, remember, you can turn off the atmosphere and the ground. Now you need a ground for this lab because that's basically where the horizon, that's your point of reference. You also want to have the constellations there for a few of the questions. Let's start. I mean, what is what you will be doing? Here it says you're gonna go to March 25th, 6:50 a.m. So in the year 2025, March 25. And there is a reason why we choose this date, right? And remember 6:50 or 6:50. Don't forget to stop time there. Or to pause it. And then you don't see the sun, it's about to rise. It's basically the spring equinox, right? So what is the sun? To look for the sun, guys, you will do this. I will just go and look for the sun like this. So you cannot see it. It's close to the east because it's about to rise. You can remove the ground and see how it's there, okay? But you click on it and you have the list. So in what position? So basically on east, right? Is the sun due east? Technically, yes, right? Maybe not exactly due east, but northeast, east. What is the altitude of the sun? Okay, so for the altitude, you can find it here. I don't know if you guys can see that. It's below the horizon. So respect to the horizon, it's negative 7 degrees, 50 arc minutes, 25 arc seconds. Okay, and don't be surprised that the declination is not the same. Okay, and we're gonna go over that in this lab. Like you're gonna compare what the altitude means and what the declination is. So you have to write the definition of altitude. Okay, so the declination, guys. The declination is, if you use J2000, is 1 degree, right? So it's positive because the declination is based on the celestial equator. The celestial equator is basically, if you remember from the celestial sphere, is the extension of the equator. And when you have the intersection between the equator and the ecliptic, you see that 23.5 degrees difference, right? And that is basically another point of reference. So the difference is just a point of reference between the altitude and the declination. All right, so that should help you answer that question. All right, and then yes, you need the constellations because it's asking you, and we can remove the ground for that, which constellation is closer to the sun, so we can activate the labels. And it's Pisces. Now, in the constellations lab, you learn what the position of the sun means with respect to these zodiac constellations. So basically, you can use that knowledge to answer that's the search. So you can look for the constellation that you should be in March 25th. It's not going to be Pisces. So you can answer this question. And then, is this what you thought the sun was, your sun sign was all along? So basically the same questions as the constellations lab. There is a difference between what the astrology calendar says and what you see actually in real life. That's the idea behind this question, so it's pretty simple. Now we're going to go to the azimuth angle, okay? So we're going to be looking at the azimuth grid. I'm going to give you a hint for this to make it easier, all right? You're going to look at the rise of the sun on different dates. So where does the sun rise? That's easy. Where does the sun rise with respect to the east? So you're going to go to December 25th, 7:26 a.m. And that's a day here anyway, so let's take a look. First 7:26 a.m. Yeah. Okay, so we can activate the ground again. So it's basically, it's not really east, right? It's more in the southeast. So where is the sun? Where? You need to know the position, right? So you want to activate the azimuth, remove the ground, and then look where the sun is with respect to this here. Now, if you don't want to use that, and you want to do respect to the east, right? And east is basically 90 degrees here, right? So you can do a subtraction with the azimuth, and you can find that in, so you have here the azimuth, 116 degrees. Yeah, so 116 degrees, that's the azimuth angle, right? With respect to the east, will be 116 minus 9, so 116 point, no, 116 minus 90, you're looking at 26 degrees different, right? Now, you can also, if you find this easier, you can also do the angular measure tool, guys. This will be more accurate, I think. 27 degrees, 11 arc minus 26. So you can use the angular measure tool, right? And it will give you the angular distance. And you can basically fill in the whole table using that. So for example, if you go to June 21st, June 21st is the summer solstice. So if you go to June 21st at any time, to be honest, but let's go to 5:32 a.m. It's basically when the sun is gonna rise, right? If you look at the ground, yeah, it's about there. Now is, before it was on the right? So now if you look at here, the azimuth is now 53 degrees. Yeah, change a lot. So you technically don't need the grid lines. You can use that, but. So it's now 37 degrees. Yeah, 90 minus 53, so there you are, right? So you can use that, and you can fill in this table, the angular distance, basically. So, and then you can answer, how does the sun move? You can say that goes on the left of the, or to the southeast, to the northeast, right? How does the sun move from this? So this is just based on this angular distance. This is not difficult at all, okay? And then we're gonna look at the altitude. For the altitude, you are gonna be looking at the altitude of the sun. So that's actually quite interesting because we can go and we can still use this, and you can observe the altitude of the sun at this time. So actually, let's go farther on time. Let's actually go at 7:30 a.m. And if you go to mid to noon, the altitude is 70 degrees. It's very high in the sky. But if you go to the winter solstice at the same time, oh wait, yeah, it's 28 degrees. It's less than half. So that explains the seasons, and that explains, well, basically the duration of the day and all that, right? So that basically helps you to answer questions like this. What's the sun? Let's look at the table there. According to the readings, so this is based on the readings, and then to find the altitude of the sun, guys, just go in here altitude, azimuth and altitude. Pretty much that's what you have to do, okay? And then for the sun at the equator, I don't know if you guys have been here. I was there last year. If you go to Quito, you can find the 0 latitude. It's a nice tour. You can actually visit the point of 0 degrees, 0 arc minutes, 0 arc seconds on the world, right? But it's basically in Quito, so we're gonna go there right now. You should move this now. You can go to location, Quito, Southern America. You're gonna activate, you're gonna turn off the atmosphere, you're gonna turn on the equatorial grid, and then you're gonna look at the latitude from the equator. June 21st, 617. So let's go there. That one you have to estimate, okay? So this is the lines of the equator. Oh, wait, what happened here? That's okay. June 21st, 6:17 a.m. Let's turn on the ground. Let's look for the sun again. And you want to remove the ground again. And yeah, that's what I want. So you see, on the summer solstice, the sun is basically rising at 6:17 a.m. And you are basically at a latitude of 6 hours, right? It correlates with the time, but there you have it. And I know because of this is a line. The latitude correlates with the right ascension, which is measured in hours, minutes, and seconds. Okay, so you can use that. All right. You can also write this latitude here, but if you use equatorial grid, that's fine. This is an estimate, okay? And you want to see what happens as you go downwards. So for example, August 9, 6:20 a.m., August 9, 6:20 a.m. So you are about 9 hours and 20 minutes. Well, there it is. So you're gonna learn that. And that's one of the things I learned in astronomy when I was doing observations outside. Right ascension correlates with latitudes in Earth measurements. And declination correlates with altitude, sort of, right? In terms of units, at least. So there you have it. That's what you do. Okay, so you can always use this to help you out. And then you're gonna answer what is the farthest latitude, when does this happen? So you just fill in this table and then you look at which is the farthest, right? And that's pretty much for this lab. Nothing out of the extraordinary. If you have difficulties with one of these questions, please reach out. All right. By this time, you should be feeling comfortable or more comfortable with Stellarium. So make sure that you go over the lab and give enough time to answer questions. All right. Have a nice day, guys, and see you on the next video. Take care.